Half reactions. Welcome back to the Back to Basics for electrochemical reactions. We are going to revise the basics of how to use half reactions and combining them into net ionic or full reactions. First, it's important to know how to see if an oxidation reaction or a reduction reaction is shown. There are few ways to see them, but it's important to remember that oxidation is loss of electrons, while reduction is the gain of electrons. You can remember this by knowing the words oil rig. Oxidation is loss, reduction is gain. So, how do we see if electrons are gained or lost? By looking at the reactions. Well, it's easy if you understand how reactions are shown. On the left, the reactants go in. The right is what comes out. So, if electrons are going in, they are joining something. That means that electrons are gained, and this reaction must be a reduction reaction. Oxidation can be a little trickier because we see the electrons on the right. Let's be very clear. This means they are coming out of the reaction. That means that something lost the electrons. If electrons are lost, we see them on the right side of the equation. When you write down half reactions, you might see things that just don't make sense. In this example, chlorine is written as a single atom, but we find it as a diatomic element. So, let's fix that. Now, make sure that atoms balance out. Now, make sure that the charges balance out by multiplying the electrons by 2 as well. Now, if we are to make a compound with potassium, we can use the oxidation reaction for that. Potassium makes a positive ion and electron. You might have seen the problem with putting these two reactions together. The chlorine reaction needs 2 electrons, but the potassium reaction only makes 1. So, the most important step before making a net ionic reaction is balancing the electrons. The way to do that is to find the LCM, or lowest common multiple. 2 from the chlorine, 1 from the potassium means that the lowest common multiple is 2. So, we need to multiply the potassium reaction by 2 to make the electrons equal. Be sure to multiply everything by 2. Now, when the two reactions are written with everything on the left together and everything on the right together, the electrons are balanced. Because the electrons are 2 on each side, we can remove them. They are usually not even written during this step. Let's look at the oxidation of aluminium using oxygen from the air. We start with 2 half reactions and labeling them. The aluminium is clearly losing the 3 electrons, so this is oxidation. The oxygen is gaining the electrons, and this means that oxygen is being reduced. Next, we'll look at the half reactions, balancing the electrons. Oxygen has got 4, while aluminium has 3 in the half reaction. That's very tricky. The LCM is 12, so multiply the aluminium by 3 and the oxygen by 4. That means 12 electrons in and 12 electrons out. writing everything together means that we get 4 aluminium atoms in, 3 oxygen molecules as reactants. We get 4 aluminium ions out, 6 oxygen ions out. Wow, not too bad though. Now, writing these half reactions out or working them out is really tough. Another thing you might be wondering is how to tell which element is going to reduce and which one is going to oxidize. For that, we'll use the table of standard reduction potentials. But that's a topic for another Back to Basics video.